Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to Social Science online classes. The topic that we are discussing is complex numbers. In the previous class, I just introduced the concept of modulus and conjugation. Correct? Now, I'll just recall quickly. If z is a plus I, if z is any complex number, ಯಾವುದೇ complex number ತಗೊಳ್ಳಿ z ಅಂತ ಅದನ್ನು consider ಮಾಡಿ. Then what is modulus? So modulus of z is the square root of a square plus b square, right? Similarly, conjugate. This is the notation z bar. So that is a minus id. So these are the two things that you need to remember for the next few problems. Well, we'll continue to discuss about this modulus and conjugate. We have a few properties. Okay. So before that, I want to give you a very important formula for multiplicative inverse. Okay. So ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ ನಾನು ಮಲ್ಟಿಪ್ಲಿಕೇಟಿವ್ ಇನ್ವರ್ಸ್. Right. So you have a complex number z. So let z is equal to a plus ib be a complex number. Right. So be a complex number. Now, as you know, I'll start from the beginning of this. Okay. Number already 5 into illon number name very big. So same number you should write here also. Same number here. Find the answer in the video. Identity element for multiplication. So multiplication ಗೆ identity ಏನು 1. ಸರಿನಾ? ಇವಾಗ ಇಲ್ಲಿ ಯಾವ ನಂಬರ್ ಬರುತ್ತೆ 1/5 is it not? So what you understand is 1/5 is the multiplicative inverse of 5. Okay, so when you multiply the number with its inverse, you should get identity. That is the concept of this inverse, right? You can take some other example if you need. So this will be 1/6 then, and this is 1/6 into 6. So you should get all this identity. This will change. Okay. So for a particular number, you will get a unique inverse. Okay. You don't get the same inverse. So for every number, it changes. Identity must be same. Alright. So remember this concept of multiplicative inverse when we understand about complex numbers now. Now, if z is a complex number, what is its multiplicative inverse? Then its multiplicative inverse is so what is its multiplicative inverse? It will be 1/z or z to the power minus 1. Right. So either 1/z or z to the power minus 1. So z into 1/z, that is equal to 1/z into z will be equal to 1 because 1 is the identity for multiplication complex numbers. Okay. So this is like 1 plus I0. Alright. So 1/z, or you can write See, I'll start with the z inverse. That is equal to 1 by z, correct? And that is equal to 1 by a plus ib. So what am I doing? I'm just replacing z. Z place will be a plus ib. Next, in multiplication. Next, you know the multiplicative inverse already. You know no problem at all. So this is like rationalization. So what you need to do is multiply and divide by the conjugate. So what is the conjugate? So conjugate is if a plus ib is z, then a minus ib is the conjugate. Conjugate ಏನಾಗುತ್ತೆ? Real number same ಇರುತ್ತೆ. Imaginary part sign change ಆಗುತ್ತೆ. Right. So that is about the conjugate. Now what are you doing? Multiply and divide by the conjugate. Okay. So that is rationalization. Now multiply the numerators. So what you have is a minus ib into 1. So that is a minus ib itself. Divided by, so this is a plus ib, a minus ib, a plus b into a minus b. That is a square minus b square. So this is like a square minus I square b square. It's like ib whole square. Okay. Well, the next thing, this is a minus ib, this is a square. I square is minus 1. So hence you will get a square plus b square minus into minus. Now you have two formulas. One is z bar, that is a minus ib, and what is mod z? Mod z is square root of a square plus b square. I told you beginning of today's class. Okay. Now what is the square of this? So if you square here, you must square here also. So square root will get cancelled, correct? So you will get b square plus b square. ಎರಡು ಕಡೆ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಆ ಕಡೆ ಸ್ಕ್ವೇರ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. Right. Now you tell me what should I write in this place? Can I write conjugate? Yes. So this is nothing but z bar divided by what is this? A square plus b square modulus of z whole square. So this is modulus of z square. And what about the LHS? Z inverse, or you can write 1 by z. Well, from this we will get a very important formula. Alright, remember multiplicative inverse is this formula. So what is multiplicative inverse? Z bar by modulus of z square. So multiplicative inverse of a complex number z is z bar divided by modulus of z square. That is 1 by z, or z inverse. So z inverse is equal to z bar divided by mod z square. So this is the formula you have to remember. Right. So what is the inverse of z? Z inverse, and that is z bar by modulus of z square. Well, now I'll continue and give you one more formula. Alright. So now 1 by z is equal to z bar divided by mod z square. So if you cross multiply z into z bar, that is equal to 1 into modulus of z square. So this is one more formula, and this formula is very important for competitive exams. Okay, so if you know this formula, you can solve the problem very quickly. So remember this formula. Right. So z into z bar is equal to modulus of z if you need an example for this, let me give an example. Alright, so understand I am taking a complex number. So let us say z is equal to 2 plus 5I, let us say. Right. Now, what is z bar? Z bar means conjugate. Real part remains the same and imaginary part changes the sign. So plus becomes minus. Plus and then minus. Okay. So this is z bar. Now, what is z into z bar? Alright. So z into z bar. So that is like 2 plus 5y into 2 minus 5y. So what is it actually? A plus b into a minus b. So a square minus b square. So this is like 4 minus 25 I square. So 5 square I square. Okay. Now I square is minus 1. So this becomes plus. So this is 4 plus 25. So what is it? 29. Alright. So is it equal to modulus of z square? Yes, because modulus of z is square root of a square plus b square. So what is a square? 2 square plus b square. So that is 4 plus 25 and that is square root of 29. Right? So square root of 29, that is modulus of z. So modulus of z square and 29. So I hope you understood this formula. So z into z bar is still a calculation model avashyakate illa. So this calculation model answer directly baribodu if the question is z into z bar. So I hope you understood the usefulness of this formula. Okay. This formula tumba ಕೆಲಸಗಳನ್ನು ಕಡಿಮೆ ಮಾಡುತ್ತೆ. It saves the time and energy. Okay. Well, a few properties, right? So for any two complex numbers, Z1 and Z2, you can have the following properties. Right. So the first one is Z1 into Z2 modulus. So if you want to find the modulus of Z1 into Z2, what do you need to do? Z1 and Z2 multiply ಮಾಡಬೇಕು ಅಲ್ವಾ? So ಅದು ಮಾಡಬಹುದು. You can find the modulus of Z1 and modulus of Z2. Then multiply them. So that will be easy. So modulus of Z1 will be like this, some number. Okay. So multiplying those numbers will be easier than multiplying each and every part of the complex numbers. Okay. So that multiplication will be time consuming. Well, so next formula is if you have Z1 divided by Z2 and you have to find its modulus. So in this case also ಇಲ್ಲಿ ಡಿವಿಷನ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ, ರಾಷನಲೈಸೇಷನ್ ಎಲ್ಲ ಮಾಡಬೇಕಾಗುತ್ತೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಗಳನ್ನು ಡಿವೈಡ್ ಮಾಡುವಾಗ ಅಲ್ವಾ. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಟ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಡೂ ಇಸ್ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ದ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ದ ನ್ಯೂಮರೇಟರ್ and modulus of the denominator separately. Okay, so provided not equal to 0. Okay, so this modulus of Z2 should not be equal to 0. So if it is 0, then this does not exist. It becomes infinity. Correct. So that should not be equal to 0. Then this formula can be used. So that is about two formulas for modulus. Now there are few formulas for conjugate as well. Okay. Well, the first formula for conjugate, we'll just continue the numbers. See what is happening here? This is Z1 plus Z2 or Z1 minus Z2. So two formulas are written in one sentence. Okay. So this is equal to Z1 bar plus or minus Z2 bar. So we can find their conjugates separately. Alright. Next, this is for addition or subtraction. Now multiplication and division. Okay. So Z1 into Z2 whole conjugate is equal to, you can guess the answer here. So you can find the conjugate separately and multiply. Well, so the last formula for division. So this is equal to Z1 conjugate divided by Z2 conjugate. Alright. So provided Z2 is not equal to 0. So this Z2 should not be 0. If Z2 is 0, then Z2 bar will also be 0. Okay, then both will not be defined. Alright. So Z2 should not be 0, then only we can use this formula. Then only this division will exist, otherwise it does not exist. Okay. You cannot divide anything by 0. Okay. So these are a few formulas. These formulas will help you in competitive exams. For this NCERT syllabus, you don't use these formulas much. Okay. So this chapter is all about the introduction to complex numbers. So you don't have very complicated problems here. You have all the simple problems here. But for competitive exams, they can give you complicated questions. So there you need to use these formulas. Well, so learn these formulas. It's not much to remember here. Okay. So instead of multiplying and then finding the modulus, you find the modulus separately and multiply the numbers. Okay. So that's the logic behind this. Well. Well, we have learned a few formulas. Now let's use them. The first one being finding multiplicative inverse. Okay. So find the example problem. Find the multiplicative inverse of 2 minus 3i. Alright. So what is the multiplicative inverse formula? Multiplicative inverse formula is z bar divided by mod z square. Right? You remember this? Please learn this. Okay, now itself take it to your memory. Alright. So store in your memory. Alright. So z inverse is equal to z bar conjugate divided by the square of the modulus. Okay. So modulus square. So now what are the two things we need to find if you have to find multiplicative inverse? What do you need? Z inverse. What do you need to find? These two things. So we will find z bar first. So before that, let me fix this as z. Now, what is z bar? So z bar is the conjugate. Conjugate means the real part remains the same. Imaginary part changes the sign. That means this negative becomes positive here. Okay. Next, we will find the modulus. So what is the modulus formula? Square root of a square plus b square. That is equal to square root of 2 square plus minus That is nothing but square root of 4 plus, see remember this is b square, so this I does not come here. Alright. So what is minus 3 square? That is plus 9, and it is square root of 13. Well, now we can write the multiplicative inverse. Therefore, the multiplicative inverse multiplicative inverse is this itself, and that is equal to, what is the conjugate? So conjugate 2 plus 3i divided by, so this is mod z, now root 13 square. So finally it is 2 plus 3i divided by 13, hence you can just split the numerators and write. So this will be 2 by 13 plus I into 3 by 13. So this is the way you can write any complex number, a plus ib. Okay, so finally write your answer in that form. So I hope this part is clear to you. Alright, so this is just 1 mark or sometimes 2 mark question. Find the multiplicative inverse. So you can directly start from here. Okay, and z bar you can directly write mod z, you can write square root of a square plus b square and then simplify. Okay, or you can find these two things first, then substitute. The option is yours. Alright, so let's solve one more example. Alright, so the next example is express the following. In the form of a plus ib. Alright, so you have the first sub question. The first sub question is 5 plus root 2i divided by 5 1 minus root 2i. Well, so the answer, what you have to do here, see this is division of two complex numbers. In the denominator you should not have any complex thing. See, in this case, if you want to write in the form of a plus ib, here I should not be there in the denominator, correct? So that should be a real number, then only you can shift them and you can get the real part separate and the imaginary part separate. So you have to get rid of this complex number in the denominator. So which method do you use? Rationalization. So what you have to do is multiply and divide by the conjugate of the denominator. So conjugate of the denominator रहता है, denominator का conjugate रहता है. इसलिए real part same रहता है, one imaginary part will change the sign. So understand? So this is 5 plus root 2i divided by 1 minus root 2i. Now we got to multiply. Real part same, imaginary part changes the sign. So plus root 2i divided by here 1 plus root 2i. Okay, so why are we doing this actually? See, in the denominator you have a minus b, this will be a plus b, a square minus b square, you will get I square calculated as minus 1. So denominator ಯಾವುದೇ complex number ಇರಲ್ಲ, ಯಾವುದೇ imaginary part ಇರೋದಿಲ್ಲ. So because of that reason we are multiplying and dividing by its conjugate. I hope you understood why we are doing this. So let's continue. Well, so multiply. Alright. So 1 by 1. So 5 into 1. Then 5 into root 2i. Then root 2i into 1. And then root 2 into root 2. That is 2i into I. That will be I square divided by. So this is a minus b into a plus b. We can write a square minus b square directly. So this is 1 square minus root 2y square. Okay, so this is like a square minus b square. A minus b into a plus b. Okay. Well, now let's simplify. We'll replace I square. So 5. See, this is 5 times root 2y. This is once root 2y. So just add them. So 5 plus 1. So that will be 6 root 2i. And this is 2 into minus 1 divided by. So 1 square divided 1. And then, see, this is root 2 square. Square root of 2 whole square is 2. And next is I square. So this is 5. And this is 2 into minus 1. So minus 2. And then 6 root y divided by. So this is 1 minus 2 into minus 1. So this is 5 minus 2, which is 3. And this is 6 root y divided by 1 plus 2. So 1 plus 2 is 3. You can take 3 common out of this. So this will be 1 here. And 6. From 6, you have to take 3 out. So what will remain is 2. And the remaining things are same, correct? Divided by 1 plus 2. So you can cancel out this 3. And your final answer is 1 plus 2i. So this is in the form of a plus id, right? So you have a is equal to 1 and b is 2 root 2. So that's how you can solve any problem when you have division. So just multiply and divide by the conjugate. So rationalization is done here. Let us continue and solve one more example. So this is the first one. Now the second one is I raised to minus 35. Okay, so I raised to minus 35 you can solve in two methods. We have done this. I raised to minus 39. Remember? Okay, so minus 35, right? Well, see, I'll give the formulas again. I think you have forgotten. So, what is I raised to 4k? So that will be 1. Then I raised to 4k plus 1. Imagine k is 0, I raised to 1 is I. And then I raised to 4k plus 2. That is like I square if k is 0. Okay, so minus 1. And then I raised to 4k plus 3 is minus I. That is like I cube. Okay, that's the easiest way of remembering. I have told you already. Okay, so you can use the formulas. Now, I raised to minus 35 can be written as I raised to 4 into any integer there plus either 0 plus 0 here plus 1 plus 2 or plus 3. Now depends on this number. So which number can you put it here? You can put minus 9. So if you put minus 9 there, if you put minus 9 there, 4 into minus 9 is minus 36. So this will be minus 36 and plus 1 will give you minus 35. Is it not? Well, so that's still even number there. Okay, so now this is of the form I raised to 4k plus 1, therefore the answer is I. Therefore the answer is I. So you can use the formulas and solve this problem in a easier way. So if you are not in a position to recall the formulas during the exam, let us say, okay, you have the alternative method. So the alternative method is alternatively I raised to minus 35 can be written as 1 by I raised to 35. Okay, so minus 35 in the numerator. So when it comes to the denominator, that power will become positive. Now I raised to 35 is there now. So you have to write it as 34 plus 1. So you can write I raised to 34 into I. Well, the next thing, 1 by I square. See why I am writing in square? Because I square is minus 1. That is a well-known formula. Okay, so I square, and how much is remaining here? 17. And then I raised to 1. Correct? So 34 plus 1 is 35. So this separation I hope you have understood. Okay, and this is like 2 into 17. So I square to the power 17 I am writing here. Okay, well, now what I can do is replace I square, that will give me the answer. So this is 1 by minus 1 to the power 17 into I. Right. So what is this? So this is like 1 by minus I, see I minus 1 to the power 17. So if you have odd power, that will be minus itself. So this is 1 by minus I. Now you have to rationalize. See, if you have A plus IB, what you multiply and divide? A minus I. Correct? Now what you have is 0 minus I. So multiply and divide by 0. Real part same, but imaginary part changes the sign. So changes the sign and becomes plus. So you have to multiply and divide by I. So multiply and divide by I. So this is like 1 into I, and minus I into I is I square. Okay, so I divided by I square is minus 1, and minus into minus is plus. So that is I by 1, which is like I. So if you know the formula, this is so much easier. But if you don't know the formula, then you got to do this much. Okay, so that is about the example. Now there are a few exercise problems regarding multiplicative inverse. Okay, so there are 3 problems to be precise. So exercise 5.1, the same exercise, but a few problems we had left unsolved. Okay. Find the multiplicative inverse of the following. The first one, the continued number is given. So 11th question, okay, till 10 we have to solve. 4 minus 3i. Okay. So first what you do is, when you write the answer, you consider the given things as z. Then what is the multiplicative inverse? multiplicative inverse is Z inverse is equal to, see, you got to remember the formula here. Okay, so what is the formula? Z inverse is equal to Z bar divided by mod Z square. Now what are the two things you have to replace? Z bar, what is Z bar? Conjugate of Z. So conjugate of Z. Now what do you mean by conjugate of Z? Conjugate of Z means real part same, imaginary part change the sign. Okay, so Z inverse is equal to Z bar is nothing but 4 plus 3i. So this is 4 plus 3i divided by modulus of Z. So what is the modulus of Z? Square root of a square plus b square. Okay, so a square means 4 square plus minus 3 whole square and then square of this. See why you need that square? Because modulus of Z is square root and this square we got to write as b's. Okay. So this is the reason. Well, so this is 4 plus 3i. Then square root and square we can cancel off. So 4 square 16 plus minus 3 square minus 3 into minus 3 plus 9. So this is like 4 plus 3i divided by 16 plus 9 is 25. So finally you can split them and write. So this is 4 by 25 plus I into 3 by 25. So what is done here? Take the denominator here, separate them, and take this denominator here also. So 3i by 25. So I have written I first and then 3 by 25. So that's how you can split them and write. So that is the question number 11. Now, the next question is question number 12, right? And that is root 5 plus 3i. The general question is same, find the multiplicative inverse. So, before you begin the answer, write the given complex number as Z. Okay. So, if you find that method difficult, we'll follow this. So we'll find Z bar first. Okay. So what is Z bar? Root 5 same. Imaginary part changes the sign. So minus 3. Right. Then mod Z square. Okay. So what is mod Z first? Square root of a square. I'll write the formula for you. Then so now replace a. So a is root 5 plus. Now what is b? B is 3. Okay, so that is square. Now root 5 and square, that is root 5 into root 5, that is 5 plus 9. So that is like root 14. Right? Okay, and that is mod Z. Now what is mod Z square? Root 14 square, which is like 14. So finally, therefore, the multiplicative inverse. So the multiplicative inverse is Z inverse is equal to Z bar divided by modulus square. Okay. So that is nothing but root 5 minus 3i divided by mod Z square, and that is 14. this is root 5 by 40 minus I into 3 by 14. You can write this minus here. Okay. So if you want to be precise, A plus IB. You can write minus here. No marks will be deducted. No problem. But if you want perfect answer, then write in this format, A plus IB form. Okay. So that is about multiplicative inverse. There is one more question that is remaining, that is 13. And the question number 13 is the simplest one, and that is minus I. So what you need to do is, first write Z is equal to A plus IB form. So what is A here? A is 0 and plus what is B? Minus 1. Okay, so A plus IB. So finally when you simplify this, minus 1 into I becomes minus I. So minus I can be written this way. Now I hope you can continue, find Z bar, modulus of Z square, and use this formula and find the multiplicative inverse by yourself. So please do it by yourself. That's the homework problem. Alright. So please solve by yourself. That's a very simple problem, easiest problem. Well, so that's all for this multiplicative inverse. In the next class, we will continue and understand how to plot a complex number in the graph. You know how to plot a number coordinate, Cartesian coordinates, right? So you know how to draw the straight lines in the graph. So likewise, in the next class we will understand how to plot the complex numbers in the graph. So thank you for watching. Please solve this problem by yourself. Okay. So again, thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.